Hey guys, today we are starting our rational unit. So in today's lesson, we're going to do a couple things. We're going to simplify rational functions. We are going to multiply and divide them together. Okay, so first off, what is a rational expression? Okay, well, a rational expression is where two polynomials are in the form of a fraction. So we're dividing two polynomials, okay? One in the numerator, one in the denominator. The key to simplifying these rational expressions is being able to factor. So let's remember some of our factoring techniques. Okay. Here, so we had greatest common factor. So that's where we looked and we saw if there was something in common I could divide out of all of my terms. In 3x squared and in 15x, I can divide both numbers by 3. I can also divide an x out of each piece. So if I divide each, if I divide each piece, here we go, by 3x, I've taken a common factor of 3x out. 3 divided by 3 is 1. X divided by x is x. Here, 15 divided by 3 is 5. X divided by x is 1, so it's not there anymore. So we have factored it to be 3x times x plus 5. And if I were to distribute it back through, I would get what I started with. All right, we had difference of squares. That's when I had two perfect squares with a minus sign in between. When I factor this, we use the conjugate of their perfect squares. So we have x plus 2, and we're going to have x minus 2. That's difference of squares. Then we had basic factoring, where we find two numbers that multiply to give us the end, and they add to give me the middle. So if I have negative 15 and 2, I need two values to multiply to give me negative 15. So that's what, 1 and 15, 3 and 5. And one of those pairs needs to also add to give me a 2 somehow. So I need to do negative because we have negative 15. So I can either do, I'm going to do 3 and 5. I could do 3 minus 5 or 5 minus 2. Well, if I do 5 minus 3, I get a positive 2. So 5 times negative 3 is negative 15. 5 minus 3 is 2. Okay. Other ways we can factor. So here, let's slide this down. We have 3x squared minus 7x minus 6. So with this one, I can't do basic factoring. There is no greatest common factor, not a difference of squares. So what we're going to have to do is we can either do factor by grouping, or we can do slip and slide for this one. I think I'm going to do slip and slide. So with slip and slide, let's remember what that is. I'm going to take this 3 and slip it to the end. So now I have x squared minus 7x. That gives me negative 18. All right, I think of what two numbers can multiply to give me negative 18, that add to give me negative 7. That is going to be negative 9 and positive 2. So I slipped my 3 to the end. This is where we have to slide or divide it out of both pieces. This simplifies to be x minus 3. Here it doesn't simplify, so I promote that 3 back to the front, and I have 3x plus 2. Okay, so there's our slip and slide method. Our next one is kind of a combination of two different ones. So first I notice I can divide something out. This has a greatest common factor. I can divide each of these pieces by the number 2. They also both share an x that I can take out. So here 2 divided by 2 is out here. X cubed, I took one x away, I am left with x squared. Here, negative 18 divided by 2 is going to give me negative 9, and then x moved out front. And now I have, what was right above it, a perfect square. So now I can split up my x squared minus 9 to be the conjugates of their square roots. So x plus 3 and x minus 3 for that one. All right. This last problem is actually missing something. There should be a little x on the end right here. Okay. So for this problem, I have 4x cubed minus 28x squared plus 48x. So each piece, I know right away I can divide an x out of all of them, okay? I can also divide each of these by the number 4. So greatest common factor here is 4x. So that moves to the front. Now we're left with x squared. This gives me a negative 7x. and this gives me a positive 12. And now I can basic factor like I did right above it. Numbers that multiply to give me 12, to add to give me negative 7. That is going to be x minus 3 and x minus 4. And that's as low as factoring as that goes. Okay, so we are going to factor today as we simplify, because we're going to have quadratics in fraction form. Okay, so we've got to remember how to factor. Okay, so if I have, here we go. So if we have rational expressions and I want to simplify them, I do have to factor each piece first. Okay, then when we simplify, we can cancel out common factors. So that means it's the same factor on top and on bottom. So looking at this, x squared minus 4 simplifies to x plus 2x minus 4. Here we have 2x cubed minus 4x squared plus 5x minus 10. That factors to 2x squared plus 5 and x minus 2. So see how they both share an x minus 2? That's a common factor. Okay? It's the same thing in the parentheses. So I can cancel those out, and we're left with just x plus 2 over 2x squared plus 5. Okay? Same thing over here. Once I factor each piece, I notice that they both have an x minus 3. So they cancel out. We're left with 3x plus 2 over x plus 5. Okay? So let's look at why this works. Okay, so let's try things with just numbers. Okay, try writing the problem below as factors to see how canceling out simplifies the problem. So let's think about this. So if I just got my calculator and I just multiply straight across, 4 times 15, well, that's 60, right? And then 9 times 28 is 252. And I go to simplify this fraction. It simplifies to 5 over 21. Okay? How does that happen? Why does that happen? Well, because there was common factors that were able to be canceled out along the way. Okay? Like 4. I can rewrite 4 to be 2 times 2. Okay? I can rewrite 9 to be 3 times 3. 15 I can rewrite as 3 times 5. 28 I'm going to rewrite as 4 times 7. Okay? So if I look at this, I can cancel out common terms. Look at this. There's a 3 up top. There's a 3 in the bottom. There is a 4, because 2 times 2 is 4, on the top, and there's a 4 on the bottom. Okay? So now look what's left. Just a 5, and down here, 3 times 7, which is 21. So that's why we need to cancel terms, okay? That's why we're able to do this. Same thing with 5 over 5x. We got to see how we have 5 and 5x. That's the same thing as having 5 over 5 and 1 over x. 5 over 5 can cancel, and we're left with just 1 over x. Okay, so canceling out common terms is essentially how we simplify fractions. You've been doing it this whole time. You just didn't know you were doing it. Okay, so let's do some with rational functions. Here we go. X squared plus 5x over x squared. Let's simplify it. So first things first, break it apart into as many factors as you can. So my top, x squared plus 5x, I can factor an x out of both of those. I have x plus 5. My denominator is just an x squared. I can split that up. I can make it x times x. So now that I have it in multiple factors, I can start canceling out common pieces. X on top, x on bottom, right? They cancel. So I'm left with x plus 5 over x. Right? Example B, there's a little bit more to do. So on the top here, we have x squared minus 5x minus 6. Slide me over here. Okay, I need to factor my top. So what multiplies to give me negative 6, but also adds to give me negative 5. That is going to be negative 6 and positive 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Okay, and my denominator is a difference of squares. So conjugates with my square roots. We're going to have x plus 1 and x minus 1. We have factored them all down. I see that they both have an x plus 1. So that leaves me with x minus 6 over x minus 1. Right? These are still in parentheses, okay? I can't go canceling out x's. I can't do that, okay? Because this x is still a factor with 6. X is not the factor. X minus 6 is the factor. So there is no common term to cancel that out with. Okay? Here we go. Here, our next one, so that's simplifying, which we do use in the process of when we multiply and divide. So it kind of leads right into it. Sometimes I will ask you for excluded values, by the way. So an excluded value is something that x cannot be equal to. So later when we solve, that's going to be really important because there's going to be a certain value that x cannot be. And that's, when it comes to fractions, it's always what makes your denominator 0. So here, my x could not be 0. It could be any other number but not 0 because my denominator is x. Here, I had x plus 1 and x minus 1 in the denominator at some point. So because of that, my x values could not be -1 or +1 because that would make one of these 0, and I can't have that. Even though one of them canceled in the end, they were both there at some point. So x could never be -1 or +1. All right? So that comes up later on in the notes, but I just want to mention it now. Okay, here we go. Let's start multiplying. So when we multiply, we're just doing more simplifying. Okay, we're going to factor everything out, just like I did with my fractions with numbers, and cancel out common pieces. As long as it's on the top and on the bottom, I don't care if it's left or right, we can cancel it out. So here, my example C, x minus 3 is already done. I can't do anything else with that. I like to put parentheses around it so I know it's a factor. And then I still have x plus 2 down here. I can factor this numerator. Multiplies to give me 6, adds to give me 5. That's going to be a +3 and a +2. And then my difference of squares down here, two perfect squares. So the conjugates with square roots, that's going to be x and 3. So simplify everything, factor everything. Then start canceling out common factors. So anything that's in the same parenthesis. So look, I have an x plus 3, minus 3, x minus 3, they cancel out. Here, x plus 3, they cancel out. Oh, look at this. X plus 2, x plus 2. It all cancels out. So guess what? What's left over? 1. This whole thing simplifies to just be 1. Everything canceled out, so we're left with just 1. Equals 1. All right, let's go over here to example D. All right, we have 4x minus 2x squared. I'm going to divide a 2 and an x out of all of that. That leaves me with a 2 and then a minus x in my numerator. Here, x squared minus 5x plus 6. So multiplies to give me 6, adds to give me a -5. We're going to do -2, -3 for this one. All right, over here, multiplies to give you 3, adds to give you -4. That's going to be -3 and -1. And then my denominator has a 2x. Okay. So everything is factored. Let's start canceling things out. Remember, they have to be the exact same. So I see 2x, 2x, they're gone. X minus 3, they're gone. Now I cannot cancel out 2 minus x and x minus 2. That's not the same factor. It's not exactly the same. They are different, okay? 5 minus 2 is not the same thing as 2 minus 5, right? I can't just switch things around. So those are done. I can't cancel those out. So what do I have left in my numerator? We have 2 minus x, and we have x minus 1. And in my denominator, we have x minus 2. Okay, and that's as low as that one can go. If you wanted to list your excluded values, I'm going to call it EV, excluded values, what x is not allowed to equal. So along the way, let's look at this. What could make any of these 0? Well, -2 would make that 0. Here would be -3, and here would be +3. So I can't let x be equal to any of those values. On this side, excluded values. All right, x cannot equal, look at your denominators. Okay, well right here, a 2 would make that 0, right? 2 minus 2, so I can't equal that. Here, 3 minus 3, so my x can't be 3. In this piece, 2 times 2, oh my gosh, 2 times 0 would make this 0, so it can't be 0 either. Okay, so again, if it was ever in the denominator, you gotta make sure that that piece, whatever I plug back in with x, which we will do in the future, it can't be any of those values. So right now it seems kind of silly, but I promise you it's gonna make sense. I just want you to get in the habit of doing it. Okay? So I want you to try one. I want you to try this one. Let me move my face. We have x over x squared minus 2x times x minus 2 and x minus 5. So I want you to pause the video, try it, and then come right back. All right, so check your work with mine. See how you did. You should get 1 over x minus 5 as your simplified rational expression after multiplying and canceling out common terms. And then also, if you did your excluded values, a 0 would make this piece equal to 0 because it's just x. Here, 2 minus 2 would be 0, so I can't be 2. And in this piece, 5 minus 5 would equal 0, so I can't let x be equal to 5. Right? Did you good? I hope you did. Now we're going to go into dividing, which might seem complicated, but guess what? You're doing the exact same thing. Okay, so to tackle division with rational expressions, you're just going to multiply them together. All you got to do is flip the second expression. Okay? And don't forget to find our excluded values along the way. So this time, since we're flipping the second fraction, both pieces of that fraction are some point in my denominator. So when I go back to find excluded values, I got to include the entire second fraction. Okay? So the first denominator, and then both pieces of my second fraction, because they were both in the bottom at some point. All right? So my first one, I have 8x squared plus 10x minus 3 over 4x squared is being divided by 4x squared over 1. Well, I'm going to go ahead and make this a fraction by putting that over 1. It's dividing, so I have to flip my second. So x squared plus 10x minus 3 all over 4x squared. I'm going to flip the second one to be 1 over 4x squared minus x. All right, now we need to start factoring pieces as low as we can. So this first numerator, you're going to hate me, but we can do slip and slide. I'm going to kind of do it over here. You can do it on a separate piece of paper. I'm going to slip 8 to the end. Make that -24. This becomes, was that -12? Nope, +12 and -2, right? 12 times -2 is -24. 12 minus 2 is 10. And I'm going to divide each piece by 8. This simplifies to what? 3 over 2. This simplifies to 1 over 4. Promote that baby back up. We have 2x plus 3 and 4x minus 1. All right, so that's how my numerator simplifies. This becomes 2x plus 3, 4x minus 1. Our denominator, I'm going to write this as 4 times x times x. I'm going to split it up as much as I can. All right, my other side. All right, we're going to split this up. 1 over, only thing I can take out of here is an x. And now I'm left with 4x minus 1. Okay, so with this problem, I did factoring. Not a whole lot canceled. I really only see one thing. It's just the 4x minus 1, right? One on top, one on bottom. They do cancel out. I mean, I have an x here and I have an x here, but they're both on the bottom, so I can't cancel those out. Okay, so let me get rid of this. This is going to simplify. So on the top, I just have a 2x plus 3. And on the bottom, I have 4xxx. So I have 4x cubed. So that's really all I could do there. Not much. Excluded values for this one. Excluded values. X could not equal. All right, so at the beginning, I have an x right here, right? If any of those are 0, it's going to mess me all up. This was just a 1, so it's fine. But once it got flipped over, let's see, what can make that 0? That's not allowed to be 0. So x also can't be 1/4, because that would make that red parentheses 0. Okay, so sometimes there's not a whole lot that cancels out, like this one. Okay, doesn't mean you did anything wrong. It just means there's not a whole lot that factors out. So that is example E. Let's go ahead and try example F. I think you have one coming up on your own. Yes, okay, so we'll do example F together. I'm going to erase what's here. So luckily this is a video. You can rewind if you need to go back and see any of this. Okay, but I need space. Okay, so example F. We have 2x plus 6 over x squared plus x minus 2, and then divided by x plus 3 over x squared plus 3x plus 2. So guess what? We're going to flip the second equation. People in the past have asked me if you can like factor first and then flip. You can. I would just be careful, because if you factor first, you might want to try to start like canceling things out, and you can't do that until after you have flipped it. So if you want to factor first, you can just flip before you start canceling things out. Okay, I'm not going to factor first with this one. I'm going to leave it just the way it is. Take it step by step. I'm going to multiply by the reciprocal of this one. Okay. Now I'm going to factor my pieces. So in my numerator on the first side, I can divide a 2 out of both of those. I'm left with just an x plus 3 up there. This denominator multiplies to give me a negative 2, adds to give me a positive 1. I'm going to do a positive to negative 1. My other side multiplies to get 2, adds to give me 3. That's going to be x plus 2. X plus 1, and my denominator is still x plus 3. Okay, so I have factored, I have flipped, and now we can start canceling things out. All right, so let's start canceling out common terms now. So I'm going to look at the top, look at the bottom. I see an x plus 3 in both places. I see an x plus 2 in both places. And that is all I have in common. So my numerator, I have a 2, and I have an x plus 1. My denominator, we just have an x minus 1. And that's as low as I can go. Again, I can't try to cancel out the x's because they're not common factors. X plus 1 is the factor. X minus 1 is the factor. Okay? So they cannot cancel out. I do need to make sure I state my excluded values. So again, it was anything that was in my denominator throughout this whole process. So let's see here. In the very beginning, here we go. So negative 2 and positive 1 would not work here. Right, that would make that 0. Here, negative 3 would make that piece 0. Second fraction, we got to do both because this started off in my bottom, right? So I also can't have negative 2, which I already have listed. And this one, I'm going to have to add the negative 1. So if this was something I was using to solve, like find the value for x, those are what x can't be. Okay. All right. Good. The next one is just an excluded values question. Okay. So I don't want you to actually solve it all the way through. I just want the excluded values. So what I want you to do, let's see here. X minus 3, that's fine, right? This is the only piece that doesn't matter because this will never, ever be in the denominator. Ever. okay? But this guy, well, he starts there and he stays there, right? X minus 6, hold on, there we go. X minus 6 starts off in the denominator, so obviously we need to look at that one. And then to solve this as a dividing problem, so I'm going to end up flipping this, so I have to also make sure I include the x plus 1 in my excluded values. All right, so let's factor this guy. Multiplies to give me 8, adds to give me negative 6. That's going to be what? X minus 4 and x minus 2. So all of these pieces I need to look at to get my excluded values. Because if any of those get a value that makes it equal to 0, the whole thing's done. We can't divide by 0. So here, this piece can't be a 4, because 4 minus 4 would be 0. This I can't plug in 2, because 2 minus 2 is 0. My blue highlight, it can't be 6, because 6 minus 6 is 0. And then the green highlight would be negative 1, right? Because negative 1 plus 1 gives me 0. So those are your excluded values. So again, the only piece we really don't care about is the very first numerator, because that never gets flipped, but my other one does. All right? Okay, it is time for you to do one. Here we go. So here we have x minus 5 over x squared minus 7x plus 10 being divided by x over x minus 2. So I want you to pause. You're going to divide, and you're going to find your excluded values, okay? So do that. Pause the video right there, and try your own. All right, check with me, see how we did. You should have simplified to be just 1 over x, and your excluded values are 5, 2, and 0. So 5 and 2 come from your first denominator. 2 also comes from your original denominator on the right-hand side, and then 0 comes from your new denominator after you flip it over. You have just an x on the bottom. Okay. Oh, we have one more. Okay, so that is just your simplifying, multiplying, and dividing, okay? There is something called a complex fraction, okay? This is called a complex fraction, okay? Meaning it's a fraction in a fraction, okay? It's just another way that we show division, so it's still just a division problem, okay? So I had the fraction of a plus b over 4 being divided by the fraction of a squared minus b squared over 4. So it's just another way to show division between two rational expressions. And we can still treat this the same way. Keep, change, flip. So that becomes a plus b over 4. Now I'm going to multiply. I'm going to flip this over. A squared minus b squared. Okay. Try to factor anything that we can. One thing I can factor of this is the difference of two squares. A squared is a perfect square. B squared is a perfect square. So that's the only thing I'm going to be able to simplify. So a plus b stays over 4. 4 over, so use my conjugates. So a plus b, a minus b. And then we can cancel out my 4s and my a plus b's. Kind of similar to the one we just did. We're left with 1 over a minus b. All right, and excluded values for this one. It's different because you have two variables, but I would say that a and b can't be 0. I guess it just depends on like the order it's in. Yeah, this one's different because there's two variables. They can't both be 0 at the same time. So, yeah, good. So that is simplifying, multiplying, and dividing. Seems weird that we're doing that first, but when we go to add and subtract, which is next, that's actually harder because when you add and subtract fractions, what do you have to have? Common denominator, okay? So that's why adding and subtracting is coming after this. So you have a worksheet, go ahead and work on it. I believe there are 8 problems of multiplying and dividing, so work on that, and I'll see you next time. Bye.